Hello, in this video we're going to look at solving equations by setting priorities. So I'm going to assume that in previous classes or lessons you've already been introduced to the concept of the order of operations or the priority of operations. Some teachers will call this BEDMAS or BODMAS depending on the language that you're using, PEDMAS. In any event, the use of the order of operations is a convention that mathematicians came to an agreement about quite a while ago that basically says the way that equations are written and that operations are written is to be interpreted in one way, the one particular way of being read and being executed so that the answers are consistent and that no matter whether you're the person solving that problem in Russia or in China or in Canada, you're going to get the same result. So it was a way to eliminate ambiguity in processes. Think of it like a recipe, if you like. So solving equations works the same way. Essentially what you will be doing is considering the priority of operations or the order of operations in reverse. So you're looking at what is the weakest or least powerful operation in the list of operations that are being done to your unknown or your variable. And then you are going to gradually unwrap that unknown until you figure out what its value is. So I've represented that here with this little deck of cards that are stacked on top of each other. And I find it helps to think of it in this way. It's kind of like if you were playing a card game and you organized your hand from lowest to highest. Okay, you already have a sense that this king is somehow higher or more powerful than the cards below it. There's a sense of a normal or accepted order for making that group of cards. The same thing is true for operations in mathematics. So if I've got an unknown, the least powerful operation that I can do to that unknown or to that given value is to add or subtract something from it. Okay, so that's my lowest card that is above that. And I've got each of these cards is double-sided. So I've got adding and subtracting. Okay, those are equal in power or in effect to that unknown. The next level up from there is multiplication. And that goes hand in hand with division. The next level up from there in terms of effect on the value of the unknown is any kind of an exponent or a power or a square root. And this hierarchy is basically showing you that, let's say I started with a value of 5 and I add 2 to it, that's going to have less of an impact than if I had 5 to the power of 2. And then the last one for this lesson is brackets or grouping symbols. And I'm using the word grouping symbols because that includes lots of different things, including fractions. A fraction is a form of grouping symbol, especially if you've got variables in either the numerator or the denominator. Okay, so let's look at a couple of problems. You'll see how I can use this stacking card model to figure that out. Okay, so we'll start with an easy one that has one step, like this. Okay, so my variable n has had 2 added to it, so I have my unknown with an addition, and then it's equal to 4. So in order to figure out what the unknown is, I'm going to have to remove this card, this addition of 2. When I remove that, it becomes a subtraction. Remove an addition is a subtraction. So to solve, n plus 2 is 4, I'm going to subtract 2. And I have to do that to both sides in order to maintain the balance. So this is, a lot of times you'll see the equation solving shown as a balance scale, maybe with algebra tiles or something like that. And it is helpful to consider it like a balance. So I'm actually balancing where that equal sign is, and I'm keeping the balance of my scale, by doing the same thing on both sides. The result of taking the plus 2 and subtracting it is now I'm left with just my unknown, in this case n, on the left-hand side. And what I'm left with on the right-hand side is 4 minus 2, which simplifies down to 2. So that's when I've got an unknown with an addition. I'll do another one here. n plus 3 equals 11. So again, on the left-hand side of my equation, I have an unknown. And the change that has been done to that unknown is had 3 added to it. The result is 11. So in order to get rid of that 3, get rid of this card that's been added here, I'm going to have to subtract. So I'm going to subtract the 3 from both sides to maintain the balance of the scale. And I will be left with n on the left-hand side. These two cancel each other out. And this is going to be 8. Like that. Now, the same basic process is true if I have an unknown that has had a value subtracted from it. So we'll do one of those just for example. N minus 5 is 12. Okay, so my unknown has had 5 subtracted from it, and it is now 12. In order to uncover that unknown, I'm going to have to add. So I'm going to say n, left-hand side plus 5, right-hand side plus 5, and that simplifies down to n is equal to 17. That's a simple one-step equation with just the purple and the blue cards. All right, let's look at another one-step equation. But this time we're going to use purple and green. So I've got an unknown that's been multiplied by some value. I'll say 3n is 21. So just a reminder, in between the 3 and the n, this 3 is a coefficient, and right in between here is a multiplication. So because my variable has been multiplied by 3, so my unknown is multiplied by 3, in order to solve for that n, in order to isolate it, I'm going to need to divide by that 3 on both sides. And I'm going to represent that with a fraction bar. Like that. And the result of that, 3 divided by 3 on the left here, cancels out, which is what I was hoping for, what I was planning for. So now my unknown is isolated, like that. And on the right-hand side, 21 divided by 3 is 7. So that's a one-step equation when the variable was multiplied by some constant. Let's do one where the variable is divided by some value. So we'll say x divided by 5 is 6. And I'm using small numbers here just to make it easier to do quickly in my head. I'm also using integer values, so the numbers are going to turn out to be whole numbers in the end for solutions. Also for ease, it's entirely possible that the values would turn out to be decimals or fractions, and that's okay too. All right, so in this case, my unknown, x, has been divided by 5. Okay, always that unknown is on the bottom. And my equal 6. In order to get rid of this division by 5, to isolate for the unknown, I'm going to need to multiply. So I'm going to write that like this. And I can choose to write times 5 to the right here or to the left. It doesn't make any difference. I'm going to write it like this. So 5 divided by 5 eliminates the 5's on the left. I'm just left with my x. And then I've got 6 times 5 on the right is 30. We'll do one more with a division. We'll say x divided by 4 is 12.5. So in order to isolate for the x, I have to get rid of this division by 4. So I'm going to multiply. So x divided by 4 times 4 is 12.5 times 4. So I've put that multiplication on both sides. Cancel, cancel, which is why we did that. And I'm left with x on the left and 12.5 times 4, which is 50 on the right. And that is how you solve one-step equations using the priority of operations.